Welcome to The Explainer. Today, we're diving into a massive shift that is fundamentally transforming the very vehicles we drive. We've spent well over a century perfecting the automobile, right? Making it faster, safer, and remarkably smarter. But automotive engineers have recently slammed headfirst into a pretty undeniable paradox. Our cars have gotten terrifyingly heavy. So today we are unpacking the definitive solution to this automotive weight paradox and exploring the composite future that's already reshaping our roads.
To really understand the sheer scale of this problem, let's look at a classic example. Think about the 1974 Volkswagen Golf MK1. It was nimble, it was extremely light, weighing in at just around 780 kilograms. Now fast forward to the 2004 VW Golf MK5. That weight ballooned to a staggering 1,300 kilograms. So why the massive gain in mass? Well, it's the incredible rise of complex electronic systems and absolutely critical crash safety regulations. We added tons of utility and life-saving safety features, but man, we paid a severe penalty in weight.
So here's the deal. We literally cannot continue on this trajectory. The modern engineering mandate is crystal clear. Vehicles must get lighter to meet incredibly strict CO2 emission standards, lower our fuel consumption, and, crucially, to handle the massive battery packs of electric vehicles, engineers desperately need to reverse this trend. But here's the catch, and it's a big one. They have to strip away the weight without sacrificing a single ounce of passenger safety or structural integrity. I mean, it sounds impossible, right? How exactly do you remove heavy metal and still stay safe?
Well, enter the absolute hero of our explainer, composite materials. By definition, these are highly engineered materials created by combining two or more distinct elements. Think of it like taking an incredibly strong reinforcement material, like high-strength carbon or glass fibers, and tightly binding it within a matrix, like a specialized epoxy resin. When you merge these distinct materials together, they produce a brand new material with physical and chemical properties that are vastly superior to what either element could ever achieve on its own. But what actually makes them so special? It's all about their specific anatomy. Unlike traditional homogeneous blocks of metal, composites are strategically built up in layers. This multi-layered structure is a real game changer. It unlocks incredible design flexibility, giving us a massively lower weight-to-density ratio, extreme damage tolerance, and high thermal resistivity. Because engineers can orient each individual layer differently, the material is robust precisely where it needs to be. You get all the strength without dragging around excess, useless weight. And this sets the stage for an epic engineering showdown that's playing out in factories right now. On one side, you have the old guard, traditional single-layer steel. It's been the undisputed backbone of the auto industry for a century. But it's heavy and inherently isotropic, meaning it has the exact same strength in all directions, whether you actually need it or not. On the other side is the future, sleek, multi-layer composite laminates tailored for unprecedented directional performance that metal just simply cannot match. All right, to truly appreciate this shift, we need to look at the raw engineering facts. If we compare traditional S355 alloy steel directly against high-strength carbon fiber, we're looking at things like tensile strength, density, and elastic modulus. And let me tell you, the contrast between these two materials is going to completely change how you view the cars you drive. Let's start with our baseline. Consider the tensile strength of standard alloy steel, 500 megapascals. Just let that foundational number sink in for a second. That 500 megapascals is the reliable, heavy-duty strength that practically built the automotive world as we know it, keeping passengers safe through decades of advancement. Now, brace yourselves for the future. 7,060 megapascals. Yes, you heard that right. That is the staggering tensile strength of high-strength carbon fiber. It is literally more than 14 times stronger than our steel baseline. I mean, that is an absolutely astronomical leap in structural integrity. It represents one of the greatest advances in the history of material science. But here is the ultimate engineering fact, the thing that makes this a true game changer. Carbon fiber achieves that immense 14-fold increase in tensile strength while weighing only about 1/4 as much as steel. Let me repeat that. 14 times stronger, 1/4 of the weight. That gives you a phenomenal specific strength, or strength-to-weight ratio. It's the absolute holy grail for an automotive engineer, dramatically multiplying the structural power of the car while shedding massive amounts of mass. Across almost every single metric, composites absolutely dominate traditional metals like steel and aluminum.
They offer vastly higher stiffness, unmatched strength, and incredible fatigue resistance. Metals are highly susceptible to fatigue and wear over time, but composites just maintain their stability, all while their weight and thermal expansion metrics plummet. So this isn't just some incremental improvement. It is a total domination of traditional manufacturing materials.
Which naturally brings us to a very logical question, the great weight safety paradox. You're probably wondering, how on earth does a material that weighs 75% less actually survive a high-speed collision? If it's so incredibly light, wouldn't it just crumple or shatter into pieces? This is exactly where the true brilliance of composite engineering is tested, out in the brutal reality of real-world crash dynamics.
Well, the secret to their survival lies in the physics of those layers we discussed earlier. Unlike a solid piece of heavy steel that just bends and transfers shock into the cabin, multi-layer laminates act completely differently upon impact. The layers actually flex, and as they undergo minimal splintering and highly controlled deformation, they actively absorb and dissipate massive amounts of deformational energy. Because they manage this crash energy so incredibly well, engineers can safely reduce the vehicle's structural weight by up to 60% while actually enhancing the overall crash safety.
Let's cement that safety argument with a specific hard number from the research. Testing shows that carbon fiber reinforced with an epoxy resin actually absorbs more deformational crash energy than steel, all while achieving a 65% reduction in weight. So, whether it's applied to the doors, the chassis, or the bumper, the data proves definitively that passenger safety is vastly enhanced, not compromised, by using lightweight composite technology.
Now, let's pivot and look toward the future. We know these materials are strong and incredibly light, but how do they fit into the biggest shift in modern automotive history? What is the missing puzzle piece for the electric vehicle revolution? EVs are amazing, for sure, but they face one massive, glaring challenge that seriously threatens to hold back their efficiency and range.
That challenge is the immense mass of electric battery packs. They are incredibly heavy. So, there is a critical synergy right now between advanced composites and EVs. Shedding heavy structural weight by using composites in the chassis, leaf springs, and body panels is frankly the only viable way to offset that heavy battery weight. By offloading this mass, composites directly extend the battery range, they completely alter the vehicle's efficiency, and vastly improve the overall power-to-weight ratio. It's exactly the technological leap EVs need to reach their full potential.
Oh, and wait, there is a fascinating, lesser-known benefit here that is absolutely vital for electric cars. Electromagnetic shielding, or EMC. High-voltage EVs produce intense electromagnetic fields, and they're packed full of sensitive electronic equipment. While specific composites, like carbon-based materials or polymers, like polyaniline, actually act as phenomenal electromagnetic shields. They block outside interference, safely confine the high-voltage EV fields, and protect the vehicle's sensitive internal electronics. This ensures the whole car operates smoothly and meets incredibly strict electromagnetic regulations.
As we wrap up this explainer, I want to leave you with a powerful, provocative thought. We've seen how composites are stronger, safer, unbelievably light, and boast futuristic properties like electromagnetic shielding and high fatigue resistance. As manufacturing methods continue to improve, including modern 3D printing of composite components, will traditional metal cars soon be viewed as heavy, obsolete relics of the past? The material shift is already happening right now, making our vehicles lighter, safer, and fully ready for an electric future. Keep your eyes on the road, because the composite future is already here.